Hello, welcome to another module in this massive open online course on the principles of CDMA, MIMO, OFDM wireless communication systems. Let us look at another aspect of CDMA in this module, which is termed as the near far problem. So, in this module let us look at another aspect, the near far problem in the CDMA systems, and this is a unique aspect of CDMA systems which is not seen before. So, to illustrate this, consider a two user CDMA scenario, and we have seen that the expression for the SINR in this two user CDMA scenario is given as mod h square P naught divided by mod h square P1 divided by n plus sigma square divided by n, where this component is the numerator is the signal power. Remember, we said this is the signal to interference plus noise ratio. The mod magnitude h square P1 divided by n is the multi-user interference, and sigma square divided by n is the noise power. This is the signal to interference plus noise ratio in a two user CDMA scenario with the channel coefficient magnitude of channel coefficient h, power of user 0 given by P naught, power of user 1 given by P1, n is the length of the spreading chord, and sigma square is the variance of the noise at the receiver. Now, let us consider the following scenario. Let us consider a scenario in which there is a base station, there is a CDMA, I have a CDMA base station, this is my base station CDMA, and there are two users, but user 1 is closer to the base station. So, I have user 1 who is very close to the base station, I have user 2 who is very far from the base station. So, basically my user 0 who is very far from the base station, and let us say I have user 1 at a distance of d1, user 0 at a distance of d0, which basically, and user 0, this is user 1 is close to the base station. So, user 1 is close to the base station, user 0 is far from the base station, d0 is the distance of user 0, d1 is the distance of user 1. We have the relation d1 or d0, let us have the relation, let us say d0 is equal to square root of n times d1, that is d0 equals square root of n times d1. If n equals 256, d0 equals square root of 256, which is 16 times d1 if n is equal to 256. So, we have a CDMA multi-user scenario in which we have two users, user 0 and user 1. User 0 is at a large distance d0, user 1 is very close to the base station. We have the relation d0 equals square root of n times d1. For instance, if n is equal to 256, then d0 is 6 square root of n, that is square root of 256, that is 16 times d1, which means the distance of user 0 is 16 times that of user 1. Alright, so we can consider this simple scenario. For instance, if user 1 is at a distance of half a kilometer, that is 500 meters, then user 0 is at a distance of 16 times half a kilometer, that is 4 kilometers. So, these are fairly far, that is 16 times half a kilometer, that is basically 8 kilometers, correct. So, if user 0 is at a distance of, let us say, 1/4 of a kilometer, then user 0 is a distance of 16 times 1/4, that is 4 kilometers, alright, and so on. So, basically now you can see that this creates a problem because the received signal power, the power at the receiver decreases with the inverse square of the distance, decreases with the square of the distance, is proportional is inversely proportional to the square of the distance. Therefore, if the transmit power is P, if power is P, then P1 is equal to P divided by d1 square, that is power decreases the square of the distance, P naught equals P divided by d naught square, but d naught is square root of n times d1. So, this is square root of n times d1 whole square, which is equal to P divided by n d1 square. Now, if I substitute this in the expression for our SINR, I have SINR equals magnitude h square times P naught, but P naught is P divided by n d1 square divided by magnitude of h square P1 divided by n, which is P divided by d1 square multiplied by n plus sigma square divided by n. And now you can clearly see that there is a problem, because if you look at this numerator, I have the signal power, and on the denominator I have the interference power. And there is clearly a problem, because the signal power is equal to the interference power, and therefore, this disrupts the communication, because normally we assume that the signal to noise power ratio is very high, that is, the interference power is much smaller than the signal power. But here we are observing something very interesting, that is, a user who is very close to the base station can swarm or can basically overwhelm the signal of user 0 who is very far from the base station, that is, the signal power is becoming equal to the interference power. So, signal power, we see that the signal power is equal to our interference power, and this leads to disruption of communication because of the high interference power. Therefore, what we are seeing is that a close interfering user can basically suppress the signal of the desired user by creating a large interference power. This is known as the near far problem in a CDMA system. So, this problem, this is known as the near far So, this problem whereby a close user or close interference overwhelms or basically suppresses the signal of the desired user. So, what is the near far problem? Near far problem in a CDMA system is where a close interferer suppresses the signal of another user in the CDMA system. This is known as the near far problem in the CDMA system, and clearly you can see this leads to a disruption in communication, and therefore, in this context it is very important to control the power of the various users in the CDMA system. Therefore, what this means is it is important to power control is important power control is a very important aspect of CDMA systems, so that the users who are close to the base station transmit with a smaller power compared to the users who are very far from the base station, thereby all the user signals are received with more or less equal power at the base station, thereby one user causing a large amount of interference to another user is avoided. Therefore, power control is a very important aspect of CDMA system, and this is to avoid the near far problem, whereby a close interfering user can suppress the signal of the other users who are much farther from the base station. Alright. So, this explains the near far problem and how to solve the near far problem in a CDMA system. So, we will conclude this model here, and we will look at other modules, other aspects of wireless communication in the subsequent modules. Thank you very much.